That the topic is the LED lighting influence on employees, on workers. Please let us know if you can see us, if you can hear us.
Nie rozpoczęło się, wydaje mi się.
Hello. Hi. Welcome, everyone. I hope you can hear us and you can see us very well. Please use the chat section on the right down side. There's a chat. Please let us know if your vision and voice is clear. Is it working well? We have switched to a new camera and a new microphone. I hope it will work better than the previous one. So let us know if it works well, if you can hear us and you can see us well. Using the chat section. Hi, Tamas. Hi, Carlos. Hi, Yanis, Javier, Martin, Marius, Ravis, Sigridur, Tamas, and Vicky. Hi, everyone. I'm very happy to have you over on our 4th webinar. We will start shortly. New people are coming. All right. All right, there's 12 people already. It's 11, so we have to start. And today we'll talk about LED lighting influence on employees, on workers. This is the topic. The agenda, please use the chat on the right side below of your screen. Please post your questions. We will answer them on the go or at the end of the webinar. If your audio or video doesn't work, please let us know. When we will play a video, you can switch off the sound yourself using a voice control on your panel. And please subscribe to our YouTube channel. All the webinars will be recorded and updated there, so you will have a live. You will be updated with all the new materials that we post on our YouTube, and the same with LinkedIn. Please sign up to our LinkedIn channel. Please follow our LinkedIn LUXON LED channel, so you get new information. Within 2 weeks, we will have a new presentation about safety in street lighting. So we will talk about how the LED lighting affects the safety on the roads, concerning both the drivers and the pedestrians on the crossroads, and the safety of the environment concerning the pollution of light. So these will be the topics we'll cover within 2 weeks. You are welcome. Thursday, 11 a.m. And please subscribe to our LinkedIn and YouTube channel if you haven't done it yet. So we have 55 minutes. We have to start with the webinar. We will talk at the beginning about the basic indicators that influence the quality of light, that really influence our employees and our clients' employees. We will talk about some myths about LED lighting. Later on, we will cover how the artificial light, what's the influence on humans in different working environments, and we will try to help you find the right CRI index for your for clients' facilities, the right temperature to meet the proper comfort and well-being of employees. And at the end, we will talk about how does it affect really the working environment? What is the ROI? What is the investment in lighting, and what is the return on our employees' comfort and well-being? So I hope you find it interesting, and please keep on using the chat and posting your questions. If we don't have time to answer them all, you can send us some questions via email to our export sales team. So based on Ergonomic Institute Berlin, almost 60% of workers considered lighting a health hazard. That was in 1990s, and you have to bear in mind that since 30 years ago, a lot has changed. People require working environment to be really friendly. We have working environment with FIFA games, PlayStations. We have specific rooms just to rest, to sleep. We have a separate social rooms. Really, the society has moved much forward within last 30 years. So the expectations towards lighting have risen really significantly. I believe that the expectations towards lighting really right now are much higher than the 60% of the workers that used to consider lighting as a hazard or as an insignificant part of their working environment back in the 90s. So what are the most common misconceptions or myths about LED lighting? And we'll talk about it today. Mm-hmm. Some of them are, do the LEDs contain hazardous elements?
There were some questions, some doubts about the composition of the LEDs, that they contain, for example, carcinogenic or toxic materials, mm-hmm. such as arsenic. Basically, it depends on the LED. LEDs used in lighting, so the white LEDs don't use such materials at all. They basically use materials which are non-toxic to humans, such as nitrogen, helium, indium, gallium. So if they are not ingested, so if you don't eat LEDs yourself, then you won't have any problems with them. Yes. So
and it's different compared to CFL. So the fluorescent tubes, because they contain
every high discharge, high intensity, every discharge type of light source which used mercury. As we know, mercury vapor is neurotoxic. Can be it is bad for your health.
So if the typical CFL or high discharge luminaire dropped from the ceiling, be careful when you clean it. If the luminaire with LEDs drop from the ceiling, it's
very hard to destroy the LED, yes. And it's even harder to destroy the semiconductor inside the LED itself.
So it's really no implications on health, direct health, concerning hazardous elements included in LEDs. That's a myth, and you can check it because luminaires usually have to have the ROHS certificate, yeah. Which is checking the products that are produced on the market if they contain any hazardous elements. So if you want to check it, please ask the manufacturer for ROHS
yeah,
certificate. Exactly. Sorry for the misspelling. Does LED light pose hazards? And this usually includes the second question: does it include UV or UV or infrared or really blue light? About blue light we'll talk later, and about UV we'll talk later. So we'll answer these questions, and we'll answer the is it a myth or not. And how does the LED lighting causes migraines? Because
or does it cause
migraines? I have spoken with many clients that have said that CFL, the fluorescent tubes, were really imposing a lot of threat on health concerning the migraines. So that is real. And how do you respond to that? Is it really with CFL? And how do LEDs could do it, or do they do it?
Basically, it's possible with any artificial light source,
sure,
which uses no very smooth constant current to supply the power to it, but which uses a poor current to drive them. So a lot of low frequency ripples, such as 100 hertz, 120 hertz, depending on the outlet voltage frequency in your country, in your region. So basically, this is the 100 hertz flickering. So this is just like flickering. So very deep flickering, like 100% flicker with LEDs, with fluorescent lighting, etc. It's on the edge of the perception, visual perception for most people. So it can be visible, that flickering with the naked eye, in some cases not. But this kind of pulsation can cause health problems in people. It's strictly dependent on the individual approach. So there are people who are okay with that, and there are people who say that the fluorescent lights are flickering to them and they cannot stand them. Some other constructions could even produce an audible buzzing or hissing coming from the electromagnetic ballasts themselves, which also can, although it's quiet, it has such a frequency that in some people it can cause some kind of a fatigue or a reaction that will cause them to have a headache, migraine, etc. It's not pleasant. So it depends on the technology. And yes, with the poor LEDs, such as LED lighting, which uses sequential LED drivers with no smoothing on the output current, can also produce big flickering, which can be visible, and it can lead to the same effects. So it depends. It's not the fault of the LEDs themselves. It's always connected with the quality of the driver electronics for that.
So, and we have a first survey for you: how LED lighting affects employees at work. Is it good for humans or is it not good for humans? Please respond. This is not a tricky question. Please respond based on your knowledge, on your experience, on your client's experience. It's important for us to be open and honest. If you feel LED is not healthy and not good for well-being of employees, then we should cover that.
Yes, because as Maciej said, it depends on your experiences. So some people might say that the LED lighting is bad. So we would like to understand why are they thinking like that? Why are they saying that? And then try to explain, because very often it comes down to the very poor first experience with LED lighting back in the days, like 10 years ago, when it entered the market.
There is a survey on your panel, on your screen. Please answer the question. 7 people out of 16 only responded, so please use the survey. We have a lot to cover today, so we have to hurry. We will be very appreciative for you if you answer right now. It's only one question. All right, we get half of the answers. 8 people answered. Not to lose any more time, we will go further. So everybody who answered said the LED lighting is good for human health and well-being. If somebody disagrees, that's really good, that's okay. Please post why. We would like to understand why you think it's not good. So if you have any anti-arguments concerning the LED effects on human beings, please post. Should be okay right now.
Okay.
Sorry for the technical problem. I hope we are back. It's okay now. Great. Sorry for that.
Okay, sorry.
So coming back, we will skip this one and we will go straight to the color rendering index. Why is it so important?
Yeah, so another metric that tells you about the light quality itself is the CRI, so color rendering index. In general, it's just a metric which tells you how well does your light source reproduce colors. It's the old metric. It's based on a 15 different colors which are tested with the light source. Then you measure the brightness of each color, and based on that, you calculate the average value, which gives you the well-known CRI or RA value of at least 80, at least 90, at least 70 for your applications. So these are the classes that we divide the light sources into, but in reality, it's always somewhere in between. So if you have a LED with CRI minimum 80, then this can be in the values of 81, 82, up to 85, 86.
Okay, we are back. So it's good. So let us know if you can hear us and see us.
We had to change the camera because we have problems with the one that we used so far.
We used a very professional camera finally, and it let us down today. So I guess less professional camera is working for us better. All right. So coming back to the CRI.
Yes. So as we spoke, it's a metric which tells you how good your light source is at reproducing color. It uses these 15 colors to measure them, and basically, if you have classes like CRI minimum 70, 80, 90, then your light source cannot fall below that. Typical values can be like, for example, CRI of 81 to 86, depending on the LED type, production batch, model, etc. And the real reason why CRI itself is not a good metric, because you can have, like, for example, a CFL light with CRI 80 and LED light with CRI 80, but they could give you completely different experience in terms of how you perceive object is this one. So at the top you can see the sunlight spectrum. So as I said, it's even cut away here. So it's cut from a range of 350 nanometers to 750 in this. So it's basically from UVA to far red colors, slightly into infrared. So it's a full spectrum.
You can test it right away in Wrocław. The weather is great, so you can go outside, be on the sun, and you will feel infrared wavelengths, and you will feel it's warm. You will get a tan.
From UV,
from UV, so yeah, you can test it yourself right away.
Exactly, and as you can see, this spectrum is full. So you have every color with different brightness, and these brightnesses are determining the color temperature of the light source. And this is the color temperature of a 5,000 or 5,700 Kelvin, close to it.
If you compare the incandescent, then you have from almost no blue light to really far red lights,
yes, and a lot
including infrared. So if you take the halogen lamp, you can test it that it actually does transmit the warmth within the wavelengths.
But you cannot get a tan from that.
But you cannot get a tan, and then you take a CFL or the fluorescence.
Yes, and you can see spikes in a few colors, and then low levels of light produced in others. So basically, this CFL can be tuned to have a CRI value of, let's say, at least 70 or at least 80. But because you have such big gaps and low amount of light in other colors, when you compare it to let's say, LED, which uses more continuous spectrum. So you have a blue peak, which is very wide, then a small dip, and then the rest of the colors is continuously reproduced with the same rating of CRI 80. You may see that it's much better at reproduction of the colors from the LED than it is from the CFL, because CFL, for example, lacks saturated red color, and the LED has a slightly better amount, but lower than the incandescent and the sunlight. So if you want to have LED with CRI 90, then you will have more saturated red color most of the time, at the cost of lower efficacy, because you are now going away from the visible range. So to produce more saturated red, you have to produce slightly more light going into infrared bands. So it's a waste of energy.
So also, when we're here, we can go back to the myths. Does the LED contain UV
or
light?
IR? Basically, typical LEDs, no. They are designed to produce light from between 400 to 700 nanometers. So the 400, it's a violet color. It's a very low amount of that light. If you measure most of the LEDs and look at their spectra, you will see that basically it produces the super saturated blue, if any, because warm LEDs have very, very small blue peak, and the rest of the spectrum is dominated by the green, yellow, red colors. So
okay, and what about this hazardous blue light?
So going back to the photobiological safety,
because we can see that the natural light has a lot of blue light.
Exactly. So with the LEDs,
and CFL also have much bigger spike of
yes,
blue
and
light.
it's much narrower. So, and CFL also produces slight UV, as you can see in the far left at 360 nanometers, somewhere around. So this is UVA again. So CFL would be measured for both UV and blue light content. LEDs are measured only for blue light content, mostly because of their very small size and high brightness. So, and again, they are tested at the coldest of the offered temperatures and at highest power level that they can achieve to measure the worst case scenario. And then if you put it in the application where you use a diffuser, lens, the lower color temperatures such as 4000 Kelvin, 5000 Kelvin, and lower power levels, you will get this amount of blue light exposure lowered very much sometimes. So if you have a LED that is measured for risk group 2, so moderate risk, when you put it in the application, you can suddenly measure it as a risk group 1, so low risk group, because of the changes in the settings that you use. So the only reason why it's done is because when you have cheap LEDs with very high brightness, which are producing like color temperature of 7,000 Kelvin, for example, or even close to 8. So they are very purplish in their light, violet, blue, and very low CRI values. Then they are basically behaving like blue LEDs, and the exposure to high intensity blue light can cause, in long term, problems with the retina. So that's the only reason to have it measured and to separate the good product from the bad one.
And jumping into the light temperatures, so what would be the proper light temperature for specific manufacturing or office work? We will answer in a short second. Here we have a comparison of really warm to really cold, and some more information about the CRI.
So visual indication of what is good color rendition, what is bad color rendition. On the left, you have comparison of two light sources with the same color temperature. So sunlight, 5000 Kelvin, and cheap LED light with 5000 Kelvin, but poor CRI value. As you can see, it lacks red color, so it has all of the other colors that are produced by the sunlight, but it lacks saturated red. And when you put light source on an object that has reds in its texture, when you have red light, you can reflect that red light to your eyes. If you don't have red light, you can only reflect the closest one, that is orange light. So poor CRI light source will change the color of the object, will change your perception, which is not good for the quality control. It's very undesired because it can cause you to miss some defects in the products or completely enable you to do your job perfectly. On the right, you have the comparison of sunlight to a good quality light, artificial light source, so LED with red in its spectrum. So if you compare the two, you can see that they are very similar. So you can perform your tasks as you should be doing with that. And it depends strictly on the LED brand.
And then we have a matching of CCT for given application, and we always recommend applying the specific CCT, so the color temperature to specific needs. And you have to be aware of circadian rhythm of human beings. So it means that when you wake up, the natural light is kind of warm, soft, and throughout the day till the noon, it gets really cold light. So during the noon, like right now in Wrocław, in our facility, if we go outside, we will see a blue sky, and the light would be around 5,700 Kelvin. So coldish. And this kind of a colder temperature would be very good for high contrast work. So when you really need to apply higher contrast, Patrick will explain in a minute why do you get higher contrast from colder temperatures. So quality control or higher productivity. So throughout the day, if you have a quality control or a station where the worker goes and works really high intensity for 1 hour, 2 hours, 3 hours, then go ahead and use a colder temperature. Why the colder temperature would get us more productivity, and why it would get us this effect?
Again, it comes down to the blue light content. So from one side, blue light is considered as a hazard. So it is measured and controlled. So you do not exceed certain limits. Hence, you have the risk groups. On the other hand, because of the way that humanity evolved with the natural sunlight and the daylight cycling times, we are accustomed to changes in the daylight. So we start from the warm colors. Then when we wake up and go out with our day, we are exposed to a cool light. And then when the day comes us to the end, again, we are moving towards warmer colors, which for our ancestors meant that it's time to rest. And that stayed with us. So cool light with higher blue content, so cold temperatures, will have an effect of increased alertness on us. It will suppress the melatonin production in our bodies, which is connected with alertness, sleepiness, and the concentration. On the other hand, warm light with low blue content reverts back these changes. So our bodies start to produce more melatonin, and they are going closer and closer to the sleep mode of our bodies. So if you are going to use warm light on the production facility, you can cause your workers to be more distracted, more sleepy, less concentrated. But again, if you will use cold light all the time, this will also cause problems, because this can cause irregularities in the biological rhythm. So cool temperatures are good with high CRI for a specific task. So you have a quality control job that requires good light and high alertness, then you should use probably 5000 to 5700 Kelvin with CRI 90 to be as close as possible to a natural sunlight in that setup, where the worker works with it for a few hours a day. And then in general, we are offering 4000 Kelvin as the best color temperature, which is somewhere in between. So it's not too warm, it's not too cold, so it doesn't go into the extremes. It is a balanced amount of exposure to the blue light component and the rest of the colors, which gives you the best overall feeling if you need to be exposed to artificial light for more than 8 hours a day.
And especially if the employees work on the second or third shift, then using the cold light would be a threat to their productivity in the long term. So in a short term, the productivity will go up, but within a longer term, you could see people be more exhausted, be more tired, and making more mistakes, and taking more time off, or even taking the sick leave. Because if you use this high productivity, cold and intense light, then in the long term they will feel more tired because of that. So if you want to use high intensity cold temperatures, it's the best to use it in a short periods of time, and it's the best to use it during the day, not during the night. So we don't recommend using it on the second and third shift. That would be a threat to human health and the well-being of the workers and employees. It's important.
And plus, we don't have too much information, because all of that is in the early research stage.
Yeah, actually, the lighting research is very new branch of research at all, and the data is mostly not very accurate. All the researchers, when they do the data, they always say, well, we are just at the beginning of measuring and researching the lighting effects on human beings and the environment. So it's important for you to be careful. What is also very not promising, but it's very important to see, if you change the light at the working site, people right away see the difference, and a lot of them, especially at the production, they say, oh, you changed something, I don't like it, or why did you change anything? And you have to actually really consider that all the changes within the light will make the employees feel different. So you don't want to really push for the productivity or high intensity. If you don't need 1000 luxes, don't use it. Use 500 luxes. It's enough for precision works, mostly in most of the times.
Sometimes if you just do the proper installation, where you will reach the recommended values of intensity and uniformity with 4000 Kelvin CRI 80, this will have a bigger impact compared to the old lighting technology, which, for example, could not produce required light intensity or had a poor CRI. So only that can have a big impact.
And you can turn off the voice yourself on the screen, and here you have sodium luminaires compared with a new Lumina Ultima LED luminaires from our production. You can see a huge difference between both luminaires and what's the effect on working side. This is the power plant,
and that is 4000 Kelvin. But in order to make the recording to show any color in the sodium lamp, it had to be white balanced accordingly. So the 4000 Kelvin luminaries look like 5000 or even 5700 Kelvin.
So you see the real big difference at the beginning. Over here you see the sodium lamps, the really low low color rendering. Yeah, this is it. And the Ultima LED with 4000K, this is what we usually recommend. This is a safe pick, you will not miss it. If you are to recommend something, 4000 would be good. But for social rooms, kitchens, for places you want employees to rest, 3000 would be the best. That would be a warm light, something that is similar to the sunlight when the sun goes down. So you kind of reproduce the more comfortable environment, and this is also only recommended light source, light temperature for your home. So 3000, 2.5, 2700, that would be the best for resting, for slowing down, and for taking care of your circadian rhythm. It's very important that you understand it, that the employees wake up, they work productively throughout the day. At the end of the night of the day, they need to rest, and then at the end of the day and at the beginning, it's good to use the warmer temperatures. During the day, the colder are good. With the second and third shift, that's tricky. That's why we will recommend 4000 Kelvin as some kind of a compromise. And we have one more survey. We have a survey, and this is something we have to explain because it's not easy it's not so easy. So what increase in ROI do you expect in relation to the comfort and well-being of employees from investment in lighting? What do I mean? Let's assume you save a lot of energy, and on energy saving, our client gets 100,000 euro savings per year. So we saved so much kilowatts of energy that they saved 100,000 euro per year. Within 3 years of investment, that would be 300,000 euro. Let's assume they invested 300,000 euro, so the ROI is 3 years. This is it. But if you make the light better, you get savings on the people don't take sick leave. People are more productive. There is less accidents. There are less failures. The material, you use it less because you make more precise work and you make more less failures. So this is the ROI that we implement from the lighting, but derived from comfort and well-being of employees. So what do you think? If the client saved, let's say, 100,000 euro per year, how much that can he save from this additional benefits from well-being of employees, from their better productivity, from their better work at quality, from their better involvement, and so on and so on. So how do you think? Is it the same? Second, like 50% or 100% of ROI, so another 50 to 100,000 K? Or is it 100 to 200, so they save additional 100,000 to 200,000 euro, or is it above 500%? I don't know if I explained it well, but I tried to do it. Please answer the survey and we will jump to conclusions. 11 people, 12 people answered. Go ahead, still some more to fill in. We have 15 people, so 3 people more waiting for your answers. Okay. Let's see the results. So the results are you actually expect the results almost half of you, around 45% of people, 29% of all the people that took the part in our webinar. The result would be between 50 and 100% ROI from well-being and comfort. And the second 5 people responded that it would be 100 to 200, and only 1 person responded it's above 500%. So let's jump to our case studies, and we would be very happy if you commented. So our case study from window making company DOVISTA. So they have a huge production of window making, wooden windows, and they saw an increase in detectability at the quality control by 900%. So you can imagine what are the benefits of the client if they increase the quality control by 900%. It means they will have a lot less of the returns, and the quality of the product itself will be better. So they can actually market it and sell it as a more premium product concerning what it used to be before, because they can really take care of the quality throughout the whole process to a brand new level by 900%. And what was also important, before they used the CFL. So what Patrick was saying, there are the spikes in spectrum. So they see a little bit of, they see good the blue, they see yellow, they see orange, but they don't see actually all other colors. If you work with wooden products, then the spectrum of a light is important, but the light temperature is also important. And the client said that 4000 Kelvin is actually working much better for the employees. They feel they work a bit more productive, the comfort is higher, but what is important, they see the wood much better because the spectrum of the light allows them to do it.
And the warmer temperature causes that in this case they could spot the defects easier and faster. So instead of actually looking at the product very closely, they could only detect any defects at a glance because of the better contrast for that particular type of surface they were checking with that light.
So not only increased by 900%, but also decreased the time spent on the quality control. It's very important. And some other case studies from the world. The post office, that's not a typical post office, it was a sorting actually warehouse in Nevada, Reno. The 6% increase in productivity due to change to LED lighting led to 150% increase in ROI. So they didn't evaluate only the ROI on the savings on electricity, but they evaluated only additional ROI only from the increase of productivity. So better light, better precision, better focus of people in the long term, allows for sorting to increase the productivity by 6%. Imagine a big production facility where the turnover is in billions and you increase the productivity by 1%. If they work in billions, if the turnover is in billion and you increase the productivity by 1%, you get at least 10 million of ROI, additional ROI from that increased productivity. And here we are talking about 6%. Within Oak Creek, the client got 11.3% increase in productivity, which translated into 1,308% of ROI, additional ROI. So it's extremely important for us to look not only on the savings on the electricity, but the total cost of ownership and the real net value of this change, because it's extremely important. How to do it? The best would be to do the measurement before and after. It means ask the client what is the failure rate, how many sick leave days do they have, what's the productivity, what's the
quality increase,
quality before, what's the quality rate, and check all the parameters about the employees, the productivity, the efficiency of the work, and then check it again within a few months after implementing the LED lights. And you will find out that LED lighting is really implementing a huge increase on productivity, and that increase in productivity drives much higher ROIs than only the savings on electricity. It's extremely important. So actually the Carnegie Mellon University Center for Building Performance and Diagnostics did exactly what I told you right now. And what did they find? They found that economic ROI is big. We know, we sell the savings. We sell the electricity savings in our LED lighting business. But they compare it with economic ROI, economic and environmental ROI. It means you also check what's the CO2 emissions, what's the NOx emissions. So you check what's the influence on the environment, and you will find it in a green diagram. So if you check only electricity and money savings, direct savings on electricity, that's big savings. We know you can save 50, 70, 80%. If you combine it with environment, you get additional savings. But if you combine it with the equity ROI, it means the real impact on entire production, on the facility, on efficiency, on productivity, and finally on the human beings, on our employees, you will find out that the increase in ROI is far greater. And then using specific lighting automation, lighting control, specific light harvesting or light movements, you can increase even further those equity savings. So it's extremely important to see the big picture and to talk with the clients and to show the clients what are the real benefits and the real savings, what is the real ROI on the big picture from the investment in LEDs. And to sum up, it's of course good to understand that better lighting increases better concentration. If you use the good lighting that doesn't have this strobe effect.
Yeah, strobing, flickering. Then you will have no problems with eye strain, eye pain, headaches, migraines, all sorts of related issues for some people.
You will have lower number of mistakes. You will have what is extremely important, and you have to measure it with your clients. You have to measure the number of the failure rates, the number of mistakes, the number of accidents, because the better lighting with better parameters lowers all those risks. And this is the real threat to human being if you don't have the good enough of light. If you don't see, if they cannot concentrate, they can lose the life. And this is the biggest cost that we cannot calculate in our savings when we don't want to do it. But this is a real benefit of using good quality of the lighting. You also reduce the fatigue. We said about the accidents, and you have less waste.
Exactly, better quality control, then less waste in the production, less waste in the materials that are lost due to poor handling, poor lighting. So,
of course, most of those you can calculate into euros, dollars, PLNs, Polish zloty. So you can calculate into currency. That's sure. But you have to have the data. So we really recommend doing this before and after comparison of very broad indicators. What's the efficiency, productivity, and human being indicators that we can check and compare. And what is also important, don't compare it 1 month after implementing the lighting. There has to be a period when the people get used to new light, and then after 1 or 2 months, then you can run 1 month testing, because people react differently when there are changes. So you want to take away this this indicator that can.
You don't want your data to be damaged
Exactly.
by the too early introduction of the measurements.
Exactly. People have to get used to it, and then you want to get the measurements afterwards. And then we are sure and we know, because our clients tell us the influence is huge. Not many people measure it. Not many people take time to really get into what's the real influence on human beings in the working conditions. This is all from us. If you have questions, please post it. We are waiting for questions right now. It took us a little bit too much time today, but we had some technical issues, and this is the time that we lost. Please let us all know if this webinar was good. Was it informative? If you don't have any questions, please let us know. Was it valuable? And please subscribe to our YouTube and LinkedIn channel. And remember that within 2 weeks there will be road lighting in the road lighting and the safety on the roads. So we'll talk about light pollution, we'll talk about the crossroads sections and the safety of pedestrians, and we'll talk about the safety of the drivers. Yes, good question, Sigridur. I want to write an article about it and include it in our ebook for industry. So we have in this ebook for industry, it has 5 or 6 chapters, and we want to implement this one as a additional chapter to that. But it will take us some time because we want even to give more value, more case studies, and include more case studies of our own into this article. Thanks, Carlos. Very happy to hear that. Thanks, Javier. Very happy that you joined us today. If there are no questions, then a few more people, 4 more people are writing, so we will wait for them to write. Maybe we have to profile those customers' behavior who are interested in personal profile. I don't understand it, Thomas. It sounds interesting, but I don't get it. If you could state the question again. Yeah, maybe we should talk with not technical people, but with some economists from the where you have to pose the question again. I didn't get it. And we get from Sigrid, great, many topics. We were not aware of that. Great to hear this comment, because we want you to use those arguments, because they are very, very important. Fantastic webinar, which made me think very seriously about the lighting environment in our office in relation to well-being as well as productivity. That's correct. Don't use LED tubes, old ones especially. Don't use fluorescent tubes. This is not the perfect light.
Question, do we know disk profile analysis?
All right.
Yeah, so that kind of profiling.
Interesting, Thomas. Maybe we will talk about it in private. I think I understand right now where you're heading. All right, so we're very happy to host you. Please subscribe to YouTube channel and LinkedIn. In 2 weeks, you are welcome for street lighting webinar, and talk to you soon. You can send us more questions private to our expert sales team. Thank you very much. Bye.
Bye.